Good morning, dear students. Today we'll learn something about circles. So here in this page, that is first page, they give some three diagrams. Okay. In that I'll explain that. First one, a circle is drawn. 1 minute. A circle is drawn and one line is also drawn. So they call this as A, B. But here this is center and line AB is not touching the circle. So that's why we are called this as non-intersecting line. Okay. Then we know about circle. So with the help of compass, if we draw a circle, then we are calling the center point as center of the circle, and the distance between center and any one point on the circle, distance between center and any one point on the circle, we are calling that as radius. For example, if I name this point as A, then OA is the radius of the circle. I can consider any point on the circle and I can join. That gives the radius of the circle. And next one is the diameter. So diameter means it joins the 2 points on the circle, and that line is a straight line, or we can call that as 2 times of the radius. For example, if I extended this and if I name this point as B, then here AB is the diameter. Okay, or I can consider another straight line, so that end points of that line are PQ and PQ are on the circle, then we can call that line PQ as the diameter. And we know that diameter is 2 times of the radius. Diameter is 2 times of the radius. We know about this. And the area to find out the circle, that is the area of the circle, that is pi r square, and perimeter of the circle, that means total length of the circle, that is 2 pi r. We learned this in our earlier classes. And now if we draw one circle, okay, I will consider same circle and I will consider one line. I will name this line as S and T. Then line ST is not touching the circle. Okay, line ST is not touching the circle. That means this is non-intersecting line. Okay, line ST is non-intersecting line. So intersecting line means, so if we consider this as one line, for example, I will call this as AB, and this is another line, I will call this as CD. Then AB and CD are intersecting lines. They will meet at a particular point, or the two lines will touch each other at a particular point. I will call this point as O. Line AB and line CD will meet at point O. Okay, so that's why these two lines are called intersecting lines. And if I consider line AB, this is line AB, and this is line CD. So if we extend this, they will meet at a particular point. And if I consider another line, I'll again call the points as AB and CD. Then these two lines, if we extend this in upper side as well as in the lower side, they will not intersect. That's why we are calling this as parallel lines. Okay. So now second diagram in that is a circle is drawn of particular radius, and I'll call the center as O, and the drawn one line which contains AB as the point on the circle and line PQ. So the line PQ, okay, A and B are the points on the circle, and line PQ will pass through these 2 points. So a line which passes through the circle in 2 distinct points, then we are called that line as secant. SECANT. Okay, if a line which passes the circle in 2 different points, which passes through the circle in 2 different points, then we are calling that line as secant. And the third diagram, a circle is drawn, and they consider one point A and a line which passes through the circle only at a single point P, and this point is Q. So this is center of the circle. Okay, this is center of the circle. Line PQ is passes through the circle at a single point, that is A, when O is the center of the circle. So this point, this line here, line PQ is called tangent of the circle. Here line PQ is called tangent of the circle. In the first case, the line will not touch the circle, so that's non-intersecting line. In the second case, so this case, a line PQ is passes through the circle at 2 distinct points. So that's why this line PQ is called as secant of the circle. And third diagram tells us that if a line passes through a circle through a single point, then we call that line as tangent of the circle. If the line passes through 2 different points, then we are calling secant. If a line passes through a single point on the circle, then we are calling that line as tangent. And now tell me, how many tangents we can draw to a circle? So tangent means the line which passes through the circle at a single point. So now tell me how many tangents we can draw to a circle. Comment me fast. How many tangents we can draw to a circle? Many, infinite, 2, 4. Any other answers? Infinite, many. So yeah, I will consider the same diagram. So PQ is a tangent, which passes through the circle at point A. Now I will consider another line. I will mark one point, that is B, and I will draw one line through this point B. So this is also called tangent to a circle. Okay, because this line is also passes through the circle at single point. Then I will consider another point C. Then I will draw one line which passes through the circle. So this line is also called tangent to a circle. Then I will consider another point D. I will draw a line. So this line is also called tangent to a circle. I can consider another point E. I can draw a line which passes through the circle at single point E. So this is also called the tangent of the circle. So that's why we can draw plenty number of tangents to a circle. So now we'll come to the secant. So secant means line which passes through the circle in two distinct points. So now tell me how many secant we can draw to a circle. How many secant we can draw to a circle? Comment me first. How many second? So this is 1 second. Only one is possible. Infinite. Apart from infinite, any other answers? Okay, yes, your answer is correct. I can draw this line, this is also called secant. I can draw this line, this is also called secant. I can draw this line, this is also called secant. Now comment me which line we can consider as the having highest length in circle, which secant is having highest length in the circle, inside the circle, that is diameter. Okay, so I'll consider one line which passes through the circle through center. So if you consider this length, then this length is greater. Okay, so therefore we can draw plenty number of seconds also to a circle. So directly we will come to the exercise. In that first question, exercise 1. How many tangents can a circle have? So comment me the answer first. How many tangents can circle have? How many tangents can a circle have? Answer me first. Yes, Bhumika, Obey, Jackie, Nikhil, all are giving the answer as infinite. Yes, the answer is correct. We can draw infinite number of tangents to a circle. We can draw infinite number of tangents to a circle. The next one, next question. Second mean, in that first one, a tangent to a circle intersect it in a dash points. A tangent to a circle intersect it in a dash point. That means a tangent intersect the circle in how many points? Comment me the answer fast. So just now we learnt about non-intersecting line, intersecting line, that means tangent, and secant. So in this question they are asking about a line intersecting a circle, tangent to a circle intersect it in a dash points. That means how many points? Yes, the answer is 1. A tangent can intersect the circle at a single point. That is very important. Then third question, no, first mean, second question. A line intersecting a circle in 2 points is called a dash. So just now we learnt about tangent. That means a line which intersect the circle at a single point. We are calling that line as tangent. Now in this question they asked about a line is intersecting the circle in 2 different points. What is the name for that? What is the name for that line? Second is the answer given by many students. Yes, the answer is correct. That is secant. Then the third question, a circle can have dash parallel tangent at the most. A circle can have dash parallel tangent at the most. How many parallel tangents we can draw to a circle? Infinite, some are giving 2. Here I will draw one small circle. So this point is O. So this point is O. I called the center point as O now. Now the question is, a circle can have dash parallel tangent at the most. How many parallel tangents we can draw to a circle? So I'll take, sorry, this is called secant. I'll consider another diagram. Center is O. How many parallel tangents? I'll consider this as one line, tangent, and this another tangent, A, B, C, D. Okay, AB is one tangent and CD is one tangent, and both are parallel to each other. So because when we draw a diameter here, at the ends of the diameter the tangents are drawn. Therefore these two lines are parallel to each other, or these two tangents are parallel to each other. Similarly, if I consider this point, then this point, then these two tangents are also parallel to each other. And similarly, if I consider these two lines, then these two lines are also parallel to each other. If I consider these two lines, then these two lines are also parallel to each other. So therefore we can consider plenty number of lines. Therefore minimum we can draw 2 parallel lines, otherwise we can draw infinite. Okay, minimum 2 or maximum infinite tangent we can draw to a circle. Parallel tangent we can draw to a circle. Next, the common point of a tangent to a circle and the circle is called dash. The common point of a tangent to a circle and the circle is called dash. So that is fourth sub question in second mean. So name, if you know that, just comment me that name. So I will consider this circle. So here AB is the secant, O is the center. I will draw one tangent. I will call this point as C. I will call this point as C. So in this question they ask that, I will read the question once again, the common point, okay, the common point of a tangent to a circle, tangent to a circle, if I call this point as P and this point as Q, then this is the common point between circle and the tangent, which present point C is present on the circle. So this point we are calling as dash, that is point of contact, that is point of contact, okay, that is called as point of contact. Okay, this is about second mean. Now next one, how many of you understood this? Comment to me first. Next, third mean. A tangent PQ at a point P of a circle. First I will draw one circle. I will call this point, that is center, as O, and they ask a tangent PQ at a point P. I will draw one tangent to this circle. Tangent PQ at point P. So at point P they ask, so here P is the point of contact and Q is the another point of the tangent of circle of radius 5 centimeter. Radius given, I will join these 2 points, center and the point of contact, it is 5 centimeter. Meets the line through center O at a point Q, so that OQ is 12 centimeter. OQ is given, that is 12 centimeter. Find the length of PQ. We have to find out PQ. Okay, we know that in the construction we drawn the diagram, or we drawn the tangents to the circle, or we constructed, and in that we learned that the tangent is perpendicular to the radius. So therefore this angle is equals to 90 degree. When this angle is equals to 90 degree, to find out length PQ, we have to use Pythagoras theorem. Okay, according to Pythagoras theorem, the square of the hypotenuse side is equals to sum of the squares of the remaining 2 sides of the triangle. Okay, according to Pythagoras theorem, the square of the hypotenuse side is equals to sum of the squares of the remaining 2 sides of the triangle. Therefore hypotenuse side means the side which is opposite to 90 degree. The side which is opposite to 90 degree is OQ square, that is equals to square of the hypotenuse side is equals to sum of the squares of the remaining 2 sides of the triangle. So OQ we already considered, the remaining 2 sides are OP and another one is PQ. In this problem it is given that OQ is equals to how much? 12 centimeter. I will consider 12 square. That is equals to OP. OP is given 5 square and PQ is unknown here. We have to find out. So I will write PQ square as it is. Then 12 square, that means 12 into 12. It is 144. That is equals to 5 square is 25 plus PQ whole square. So when we rearrange this, it becomes PQ square, that is equals to 144 minus 25. 144 minus 25. Just comment me the answer first. What is the value of PQ square? What is the value of PQ square? Fast. What is the value of PQ square in this? So 144 minus 25, it is 119. But we don't want PQ square, we want PQ value. So that's why PQ becomes square root of 119 centimeter. Square root of 119 centimeter. They give the option A as 12 centimeter. They give the option B as 13 centimeter, and option C as 8.5 centimeter, and option D as square root of 119 centimeter. Option D is correct. Option D. Answer for this is option D. Okay, it comes square root of 119 centimeter. Very simple one. Just we have to solve the problem by using Pythagoras theorem. The next one, fourth one. Draw a circle and two lines parallel to a given line such that one is tangent and the other a secant to a circle. The first one is we have to draw one circle. I will draw one circle here. So I will call this center as O, and what I have to do is, first step, draw a circle. I draw one circle. The next is, and two lines parallel to a given line such that one is tangent and the other a secant to a circle. If you want to draw a tangent, then we have to go to single point. If you want to draw a circle, we have to if you want to draw a tangent secant, then we have to pass that line through two distinct points, and that two lines are parallel as well as that is parallel to a given line. So if we draw a line here, then it becomes secant. If you draw a line here, then it becomes tangent. So that's why to draw a given line, we have to draw outside the circle. Then only according to the statement our answer becomes correct. Okay, this is the given line. So I will call this as line AB. AB is the given line now. Draw a circle and two lines parallel to a given line. Given line is AB, and I have to draw now two lines which are parallel to the given line. So one is secant. So this is the given line. I will draw here, or I can draw here. So I will draw here AB, CD. CD is the another point. This is called secant, and this is given line, and tangent means I will draw another line EF, and the point is P, Q, R. Okay, this is about the first exercise. Given line, secant, and tangent. Okay, thank you everyone. I will explain the remaining in the next class. Thank you.